Good day to all. In this video lecture, let me discuss about the calorific value and problems based on GCV and NCV. Calorific value of fuels. The calorific value, high heating value of solid or liquid fuel may be defined as the amount of heat given out by complete combustion of 1 kilogram of fuel. It is expressed in kilocalories per kilogram of fuel at NTP, and in SI system joules per kilogram, kilojoules per kilogram or millijoules per kilogram. Types of calorific values of fuels. There are two types. The first type is higher calorific value or gross calorific value. The amount of heat obtained by complete combustion of fuel when the products of its combustion are cooled down to temperature of surrounding supplied air is called as higher calorific value. If carbon, hydrogen, oxygen and sulfur are the percentage of carbon, hydrogen, oxygen and sulfur by weight respectively present in a fuel, then the higher calorific value can be calculated using the Dulong's formula. By Dulong's formula, the higher calorific value or gross calorific value is given as 1 by 100 into 80 carbon plus 34 500 into hydrogen minus oxygen by 8 plus 20 to 40 sulfur kilocalories per kilogram. The second type is lower calorific value or net calorific value. It is the net heat produced when unit mass or volume of the fuel is burned completely and the products are permitted to escape. In actual practice of any fuel, the water vapor are not condensed and escape as such along with hot combustion gases. The net calorific value is given as gross calorific value minus latent heat of condensation of water vapor produced, which is equal to GCV minus mass of hydrogen into 9 into latent heat of condensation of water vapor. And hence 1 part by weight of hydrogen produces 9 part by weight of water. The latent heat of steam is 587 calories per gram and NCV is given as GCV minus 9 by 100 hydrogen into 587 kilocalories per kilogram. We'll look into the problems based on GCV and NCV. The problem number 1 is calculate the gross and net calorific values of coal having the following compositions: carbon 85%, hydrogen 8%, sulfur 1%, nitrogen 2% and ash 4%. Latent heat of steam is 587 calories per gram. Here in this given compositions, we have to consider the percentage composition of carbon, hydrogen, sulfur, and since oxygen is not given, we'll consider it as 0 and nitrogen and ash is neglected. By Dulong's formula, the HCV or GCV is given as 1 by 100 into 80 carbon plus 34 500 into hydrogen minus oxygen by 8 plus 20 to 40 sulfur kilocalories per kilogram. Now let us substitute the percentage composition of carbon, hydrogen and sulfur in this formula. Upon substituting, we'll be getting the value as 9650.4 kilocalories per kilogram. Now we'll calculate the least calorific value or net calorific value, which is given as GCV minus 9 by 100 hydrogen into 587 kilocalories per kilogram. The GCV value is 9650.4 and the percentage of hydrogen is 8, and hence upon substituting we'll be getting the value as 9227.76 kilocalories per kilogram. Problem number 2. Calculate the gross and net calorific values of a coal sample having the following composition: carbon 80%, hydrogen 7%, oxygen 3%, sulfur 3.5%, nitrogen 2.5%, and ash 4.4%. In this, let us consider the percentage compositions of carbon, hydrogen, oxygen, and sulfur. Since nitrogen and ash does not impart any calorific value, it is neglected. The HCV or GCV by Dulong's formula is calculated as 1 by 100 into 80 carbon plus 34,500 into hydrogen minus oxygen by 8 plus 20 to 40 sulfur kilocalories per kilogram. Upon substituting the values of carbon, hydrogen, oxygen and sulfur, we will be getting the value as 8828.0 kilocalories per kilogram. The LCV or NCV is calculated as GCV minus 9 by 100 hydrogen into 587 kilocalories per kilogram. And upon substituting the GCV as W28.0 and hydrogen as 7%, we'll be getting the value as 8458.2 kilocalories per kilogram. Hence, in GCV and NCV problems, if the percentage of carbon is given as 85%, substitute in the formula as 85. Similarly for hydrogen, oxygen and sulfur. If any of these composition is not given, consider it as 0. And in the problem, if they mention nitrogen and ash percentage, kindly neglect it since nitrogen and ash does not impart any calorific value. Thank you for watching this video lecture.